The Kentucky Center for Mathematics hosts an afternoon Zoom session. This week it is indeed developing multiplicative thinking. Today we are lucky enough to have our very own Leah Dix White, who is there in Louisville, Kentucky. And so we are happy to learn from her today. And Leah, I'm going to go ahead. I see 2 o'clock on the dot. I'm going to go ahead and turn it over to you. Look forward to learning from you.
Hey guys, good afternoon. We're going to be looking at some multiplication strategies for numbers beyond 100. And if we have time, we'll look at some division strategies as well. So I have a lot of things for you guys. My name is Leah Dix White. I am a regional consultant for the Kentucky Center of Mathematics, and I'm thrilled to be with all you all today for this half an hour. You can find all of our virtual PD online at kentuckymathematics.org. Be sure to check it out to get previous recorded sessions and to look for other information about upcoming sessions. So today in our session, we're going to look at the standards first and some research surrounding this topic of multiplicative thinking, and then we're going to jump right into some strategies. The strategies are mainly with multiplication, and then we have a few division strategies as well. And what I've tried to do today is to provide for you many virtual resources that you can either scan using a QR code, or you can click on the link within the PowerPoint. So there's some flexibility in how you want to interact. As always, it's great if you could send some chats in our chat box or unmute at times and participate in the discussion. It's up to you. All right, moving right along to the standards. So if we're looking at standards with multiplication, specifically we're looking at this standard where we're multiplying whole numbers up to 4-digit numbers by 1-digit number, and also looking at 2-digit number by 2-digit numbers. And if you look at the clarifications in our standards, they have lots of ways to do that. They have rectangular arrays and area model examples that are suggested you have practice with your kids exploring these different models. And there's also this connection to reasoning and writing the equation. And so these are all some great pieces of things you want to keep in mind all prior to the algorithm in reference to multiplying these numbers beyond 100. So if we're continuing with this same research that we've talked about earlier this week, we are definitely looking at mathematical reasoning in terms of multiplication. So what we mean by that is we are constantly using those algebraic and spatial reasonings throughout this continuum. But what Pam Harris emphasizes is this idea that students solve problems using bigger chunks with more than one group at a time. So it's some of those same strategies that we're used to doing with addition, except we're making it bigger, we're using bigger chunks, and we're looking at more groups with our reasoning. So those are some things to keep in mind. Another research tidbit are those instructional phases of multiplication and division. So you saw those earlier this week. And so today in particular, we're looking at that last phase where we are considering digits beyond 100. And so I've used these 2 resources, which we refer to often as the Red Book, that developing number knowledge, and also teaching student-centered mathematics, which we refer to sometimes as the Green Book. So both of those books have some commonalities, but one thing they both mentioned that I wanted to mention was this idea of how we record our multiplication. And so that's what we're going to jump in first with our first strategy. And so here we go. Our first strategy that we're going to look at are line jumps. And so I have a QR code to an interactive simulation that I'm going to show you in just a second. So if you wanted to go ahead and go there, you can. I'm going to reach that point through this URL link. But before I go there, I just wanted to show you an example of what I mean with just a 2-digit by 1-digit. So the strategy here with the line jump is to decompose this number here and think of partial products. So I can decompose 13 as 10 and 3, right? And so then I can show this on a number line with 3 hops of 10, 1, 2, 3, and then 3 hops of 3, 1, 2, 3, and then combine those together. And so this is a model that I got from the Red Book. And as you can see here, it's the same idea on a number line. We do those 3 hops, bigger chunks, more groups, 3 hops, and then we combine those 3 hops of 3 with 3 hops of 10 to give us our product at 39. And so that's what I wanted to show you all from this developing number knowledge, is this idea of recording line jumps. And so let me show you what that could look like digitally. And so here I'm going to go to this line jump simulation. And what I think is really neat about this particular simulation, and I got this from Mathematics Learning Center, is that you can create, obviously, these line pictures, and we can simulate the same situation with the hops as I did. So I can do 3 hops of 10. So here's the first hop that I can model on this number line, and I can move that here. And then I can do that same thing and another one. And then from there, I can then combine with my 3 hops of 3. So now I'm going to change this value to 3 here. And this should decrease in size. Okay. And so then once again, I'll demonstrate these 3 hops of 3. And okay, so it should be the same length. But
Leah, did the
yes.
10 length?
Yes, it should be much longer. Yes.
Gotcha.
Yes, I'm just playing around with it now, but you can extend this out. It should be to 10 here. And let me move some things along. So I thought this would be a really cool way to digitally show and record these hops. Of course, I've got to extend my 10 pieces to actually be 10, as you should have your students extend your pieces to actually reach 10 as well. So I can change this here. It has 10 here, but I want the space to be 10 spaces. There we go. And move these pieces along, and I can show these hops here. And this is just a digital version of what students can do on their paper and what you can show students depending on which form you're choosing to demonstrate information. So here, and then one thing I thought that was really cool about this is that you could write on it here and show your students this times 3. So I included that with the presentation just so that you can have some options when exploring these line hops with your students.
Yeah, I love that.
Yes.
That is really a nice visual way to do that. Fantastic.
So then if we're looking at multiplication jumps with numbers beyond 100, we can do the same thing. I kind of put a visual here. So you can do these 10 hops. We can decompose 258 and change that to 260, right? And then we can think of 10 hops of 260. And then because we went beyond the number when we made this partition, we would then subtract and go back 20 because that's at 2 hops. Remember the bigger chunks. And so then we can demonstrate the product here with a line as well. And so students can kind of get used to doing those line hops and using this line strategy to multiply prior to the algorithm. So that's one thing I really wanted to show you guys that I thought that would be cool. So the next strategy I wanted to share with you was the arrow notation multiplication. And this is also in the Red Book. And so the idea here is to record multiplication when we have numbers beyond 100, to think about those partial products here and then using arrows to denote that product. So we can think of 130 as 100 times 3, which is 300. That's a typo there. And then 3 times 3, which is 9, and that should be 300 plus 9, sorry. That's a typo there. And then you get that final product. And then once again, if we have 397 times 4, we can change that as a partial product of 400 times 4 and 3 times 4, and then subtract that from the total to get our product. And then with this last example we can decompose this number here as 200 times 5, which is 1,000, and 4 times 5, which is 20, and then find that sum. And so those are just two ways that both authors in both texts suggested we use different ways to record those notations for students prior to using the algorithm. Another notation or another model for recording multiplication is using the array or area model. And so I wanted to share with you some things. One, I have a brief video about using the array model and how to draw that. And then I have QR codes that you can go to 2 different activities that kind of demonstrate this, and just to give you some flexibility in how you show this to your students. So I'm going to show you the first video and we'll talk about it. And as you're watching the video, think about how you could use this with your students and how this would help them with representation.
Area models for multi-digit multiplication. Let's see how base 10 blocks inside Kidspiration can be used to build an array to help us solve a multiplication problem. Suppose I want to multiply 23 times 11. I'll start by setting up lines for my array. This is where I'll build the sides of my rectangle. For 23 times 11, I'll create a rectangle that has a length on one side of 23. That's 2 10s and 3 1s. And a length of 11 on the other side. That's 1 10 and 1 1. The area of this rectangle is the solution to my multiplication problem. Now we will fill in our rectangle. Let's start with the tens. I have 10 by 20. 10 by 20 gives me 200. And we'll color this red. But that's only part of my rectangle. I also have 10 by 3. 10 by 3 gives me 30. And I'll color this green. Are we done? So far, I've shown 10 by 23. But what about this 1? Well, I also have 1 by 20. This gives me 20. And last of all, I have 1 by 3. This gives me 3. We have built partial products. In other words, partial rectangles within our big rectangle. Now let's find our solution. In red, we have 10 times 20, or 200. In green, we have 10 times 3, or 30. In orange, we have 1 times 20, which is 20. And in yellow, 1 times 3, which is 3. Let's add up all these partial products to find our total product, our solution. 200 plus 20 plus 30 plus 3. Well, 20 plus 30 make 50. So altogether I have 200, 50, and 3. 253. 23 times 11 is 253. Would it matter if I switched the sides of my rectangle so that I had 23 down the side and 11 across the top? When I'm done, I still have the same partial products, 200, 20, 30, and 3, which makes a total of 253. Kidspiration.
Okay, what I really liked about that particular video, and the reason why I showed it is because it's this emphasis on the commutative property, which lends itself to algebra, right? And some other thinking. So if you wanted to unmute or add in the chat what your perceptions of using the area model and how the rows and the column structure help organize those equal groups and offer a great visual for demonstrating the distributive and commutative property. Amy says she thinks intermediate students need manipulatives more so they can see these numbers, and the visuals are great. So I just wanted to make sure you all had many examples of different area models and different array models. And here's one from Desmos. I'm just going to click to it really quick. What I like about this model is that if you're multiplying 2 digits by 2 digits, it has a slider here that you can check, and it gives a visual of the products. And so once again, you can have your students look and see how the pieces align together. And that was just from Desmos, and I have that QR code there. And then another really great area model I wanted to share with you all was from GeoGebra. And of course, I always use this because I love this site for interaction. But what's neat about this particular one is that you can show the product, you can show the partitions, and then students can make inferences about what the answer is. So here the slider will reveal and unreveal those products. And so it's great for students who want to estimate what they think the product would be prior to actually working out and talking about different strategies in finding those products. Did anyone else want to unmute and talk about any of the virtual multiplication with area models? All right, so go ahead.
One thing that I loved about it is having taught this to students, using pencil and graph paper doesn't allow for that visual partial product that I think is very powerful for a student to be able to see the visual aspect of it. And then they could use their tool to record each one of those. And so I really saw the power in that. But the GeoGebra one, where Cindy had written in there about screening, right?
Yes.
Screening and thinking about what would it be. I can see that along the trajectory of teaching kids multi-digit multiplication, and all of a sudden that GeoGebra one, the kids can already have the image in their mind's eye and see if they were right. How powerful.
Yes, thanks, Kelly. There are other area models that you can use, and we don't have time to go through each, but if you access the PowerPoint, you can just click on the links there embedded in there. There's lots of different applications of that. There's a PhET simulation where they have area model multiplication. NCTM also has some area models that you can use as well. And so let's look at division really quick. And I found this problem. I cited the source here. The problem was actually about fractions. And so I kind of modified it a little bit because I wanted to provide for you an example of area model division. And there's two ways to think about division. You can think of it as partitioning or fair sharing, or you can think about it in terms of measurement with repeated subtraction. And so you want to provide students with contextual problems that allow them to do the same thing we did with multiplication with division. And so here I have a problem, and it says the contractors say they have enough turf to cover 860 square meters. If the turf is laid in a strip that is 5 meters wide, what is the length of the strip? And then it says use the diagram to show your thinking. So here's a diagram that was provided. And so if you wanted to unmute or share in the chat rather, how would a student go about this division problem in the same way we did the area model problems? And you can unmute or you can share in the chat. Okay, Cindy's saying she might start realizing, go ahead. Or someone.
Sorry.
Go
I
ahead.
was just thinking that some of the students I work with might like turn it into a multiplication problem and think about 5 times what would get me close to 860.
Yes,
860.
definitely. That's that estimation again. And the screening, like we were talking about with the GeoGebra. Definitely. Cindy was saying that she would start by realizing that 100-meter length, and if we have 5 of those, that would give us 500 square meters. Anyone else want to share of a way to think about this problem, or how we can think of partial products with this problem?
Well, and then adding on to Cindy, if we had 1,000, it would be twice of that, and then we could subtract off to get back to the 860.
Definitely, definitely. So that's using the strategy students already know and already familiar with to get to these different types of problems, to get to the division, to get to the multiplication. And so here is just what was shared in the article, basically considering these square areas and what they would mean times 5. So breaking up those pieces and then combining those pieces in the end for some. And so I thought that was pretty neat to share. I like the visual with that, and I thought about thinking of those array and area models in a context problem. Those are good for kids too. Another problem that I wanted to share with you guys was this model, and I'll give you a couple of minutes to look about this, and you can share either in the chat or you can unmute and share which equation matches Victoria's model. And this is also thinking about partitioning or fair sharing. So I'll give you a moment to look over this one. Yay, so most people agreed that the answer is D. Does someone want to unmute and talk about the reasoning that you used to come up with D? Or was it pretty simple from the picture?
Well, I looked at looking at what was in a sector and seeing the 132, and then kind of looked at the different roles of the 132 in there, but seeing it as 3 groups of 132, which then related to the result if I split that 396 into 3 groups. But I'm going to admit, like, I didn't even get to the 396, before I was comfortable picking D. I focused in on the other numbers.
Yeah, I just looked at the answer choices though and went, wait a minute, I think they're all division, right? Yeah, they're all division. And so I went, wait a minute, so it can't be, I see 132 in each group. So I immediately went to D because it was the only one that looked, that made any, that fit at all. I didn't even figure out that they're 396 altogether. I didn't have to do that.
Cool. I also noticed that Rachel has said in the chat that she looked at the base 10 blocks and just added them all together. So that's another strategy. So I have a QR code that will take you to, this is also a Math Learning Center where you can actually model out this problem. And so if you're wanting to show students those groups, you can actually play around with this, and I shrunk the screen so that I can get all the pieces there. And then the idea is that you could even put this QR code in a Google Doc or in an assignment for your kids and give them time to explore and create the pieces and then divide them, or you can use them yourself. So I thought this was a pretty cool way to actually manipulate digitally these pieces to see what's happening. And so I wanted to share that with you. And the Math Learning Center works really good on the desktop or the iPad, not as much with the phone, but it works really good with the desktop and the iPad. So I wanted to make sure that you all had that representation as well. And so I got this actual problem from, I cited it, actually the source at the bottom of the screen, you can see, and they have some other models of division and multiplication if you want to check out that website. Some other virtual resources that I found that were really neat. There's a partial product finder here through Math Learning. There's a number line and also the number pieces, which I showed you both of those. I didn't go to the partial product finder, but it's there also. It's very similar to the GeoGebra models. And then also Glencoe has a virtual interface that's kind of like in the video where students can build those arrays, or you could even build those arrays. And so I wanted to make sure that you had that resource as well. And so any of these different resources can help you with explaining these ideas of multiplication and division beyond 100. Students can manipulate them, you can manipulate them, embed them. As far as the QR codes, that is actually a Google app. And so I pretty much, whatever website I go to, I click on the app, it gives me the code. I can embed it in any document that I'm using so that you don't have them typing in all of the URL sites, but it makes it very accessible for the kids. And so I want to make sure you all had access to that. As always, you can follow us online and get access to any of these resources that we have throughout our sessions. Or if you want to review a recorded session, they are available online as well. If you wanted to at this time, we have a few minutes if you want to unmute and share any perceptions or any feedback, that would be great. Or you can type them in the chat. That's fine too. Appreciate you guys.
Yeah, we always love those technology aspects that you add. And like Jennifer says from Austin, Texas, she says she always learns a little trick from us too. So that Google, doing the Google, where you just figure out the URL site and it gives you that Google, that QR code, how fun to be able to implement that for students and allow them access to go there lickety split. So fantastic.
Leah, how did you get your computer to read the QR codes?
It's mainly the QR codes are good for like iPads or for phones. And so I put them in there in case you're like going through the PowerPoint and you just want to hold up your iPad and then you can have them going at the same time. But if you want to get to the URL without going that way, you can just click on the link within the PowerPoint.
Okay, thank you. Because yeah, I don't have an iPad for work.
I know if you had a phone, I know Apple phones will allow you, if you just hold it up like you're going to take a picture, it'll take you directly to that site. It's just another way you can.
Yeah, my Android phone, I just had to download an app to read the QR code.
Okay.
That's not a big deal. Thank you.
You're welcome.
So we're along this journey for developing multiplicative thinking, and this Wednesday stop was on that multi-digit. I was reminded of the power of the area model once again, and the color coding that can be easily done with the virtual manipulatives. And so I always put in the chat the power of what if. So when we allow the students time to think about these models, understanding about partial product, then thinking about the inverse, Leah, I love that, which is doing the division in pieces. I've watched fourth graders be very successful with this in classrooms all across, in all classrooms that I've viewed. And it's very easy for them to think about what division really is in this idea of fair share. So we thank you so much for that. Every afternoon, you can find the Kentucky Center for Mathematics at 2 o'clock. Join us tomorrow and Friday as we continue this series. We've got more of these wonderful multi-digit multiplications for you to share with you. So we thank you.